range of motions. So the science team, which is led by the principal investigator, Scott Murchie from the Applied Physics Lab, is a little bit reticent about doing a lot of gimbaling. But this is such an important observation, I suspect I can talk him into it.
Great, thank you. Hope you have luck.
Our next question is from Irene Klotz at Reuters.
Thanks, Jane, and sorry for the background noise. I have two questions. One is, how far is the rover going to be driving a day on an average? And the other, for either Steve or Ray, is about comparing a little bit, if you're able, what you've been able to learn from the Yellowknife Bay drill samples as far as the acidity of the water or anything else, minerals, to what you found with the rock that Opportunity was studying. Thanks.
This is Steve. I can take a crack at those. To go after the second question first, I don't think any of us here want to speak for the MSL project. All of us, a number of us are involved in that project, but I think if you've got questions about what has been discovered with Yellowknife Bay, those are questions that are best put to people who are representing the Curiosity rover project. With respect to distance a day, it really varies. It depends on how much power we've got. It depends on how challenging the terrain is. The assumption that we have made is that we can achieve about 60 meters per drive between where we are and Solander Point, because that's what we've typically, historically, been able to achieve in the past. Sometimes it's better than that. We had a drive just the other day that was 102 meters. I think our most recent one was 65. But if we can maintain a steady pace of 60 meters per drive, which we have sort of demonstrated historically that we can achieve, that'll get us to Solander Point safely with a little time to spare in the calendar.
Thanks. Steve, are you able to just say in a general sense how the acidity of the water at the two sites compares?
Again, I don't want to try to speak for the Curiosity project. What we've got here is evidence for a nearly neutral pH, and we'll let Curiosity report their results.
Thanks.
Okay, I want to remind any reporters who still would like to ask a question, and we do have a few in the queue that I'm going to call on next. Just press *1 and give the operator your name and your affiliation, and we'll call on you. And time allowing, we may take a question or two from our Ustream audience. But let's go next to Sally Rail with the MER Update Planetary Society. Hi, Sally.
Hi, thank you. It's been so long since I've talked to each of you. First of all, I'd like to say congratulations 9.11 times over. And I'm wondering, I'm just going to throw this out, is there anything, you sort of touched on this a little bit with Ken's question, anything in the orbital images or CRISM data at Solander Point that you absolutely know you want to check out besides the strata, besides potential fireless silicates?
Right. Well, the strata, Sally, are the key. Right? The fact that you can see in the high-rise data the bench so well exposed, and then as you go up those 55 meters of vertical relief, you can see multiple layers. And you can see it in the PanCam that we've taken recently. You can see it in the synthetic perspective views that we make. That's where the payoff is. That's where we're going to go way beyond, I hope, what we've seen in Matijovich Hill, because there's much more vertical section and lateral section exposed, and that's what geologists use to reconstruct the past conditions, paleoclimatic and otherwise. So that's what we're after. But unfortunately, with 18 meters per pixel with CRISM today covering that area, we just don't have the spatial resolution, the along-track sharpening centered over Solander Point to really pinpoint whether there are relatively small outcrops of these special deposits that are clay-bearing.
Do you have any expectations of what you'll find there? Do you expect some repetition from what you found at Matijovich Hill?
I don't think it's repetition. I think it will build on Matijovich Hill, and I hope what we find are the layers that Steve mentioned pre-existing to Endeavour that were just uplifted and exposed, but at Solander Point, much more vertical section and much more lateral section, so we can actually see if there's cross-bedding, if we see if there are other pieces of evidence that a sedimentologist would use to reconstruct the past climatic conditions. And we also have evidence at Matievich Hill for what's called an unconformity, where these whitewater lake materials, and Esperance is a fracture within Whitewater Lake where the martrilonite was made. But overlying the Whitewater Lake materials, these very fine laminated materials that have the smectites and the martrilonite in Esperance, is the breccia. And that's an unconformity. That represents a period of time in which this pre-existing material was just unlucky to be in the place where Endeavour formed, uplifted the rim, dumped the breccia on top of it unconformably. I hope we see that contact at Solander Point, because I keep looking at the PanCam image. It is so rich. But I think once we get there, we'll be there for a while. And with those steep slopes, we may be able to be mobile during the winter and have a number of campaign stops.
Okay, thanks.
And I just have one follow-on. I know the rover got some dust cleanings in the month of May, and I'm wondering, Botany Bay could be a wind gap. Have you had any signs of wind in the last week or so?
I'll speak to that. We have had some modest dust cleaning of the solar array. Seasonally, it's kind of expected about now, but we'll see what we get further on. It's about now in past years that the wind cleaning events have kind of shut down. But we'll see if we get a wind fetch effect as we traverse across Botany Bay.
Thank you.
Okay, and we're going to take our next question. We have a few questions remaining. We're going to try to get them all in. And the next one is from Puneet Kolapara with Chemical and Engineering News, and I hope I got your name right.
Oh, yes, you did. Thank you so much. Can you hear me okay?
Absolutely.
Great. So I think, Steve, I think this was you. You said earlier that this is probably the most compelling evidence of neutral pH water that you've seen. And I think you added on that particular rover, and I just wanted to make sure, clarify that that is what I in fact heard. And if that is the case, that it was just on that rover, what about overall? I mean, can you just kind of clarify what else there was from the other rovers or from satellite imagery and that kind of thing?
Well, I don't want to speak for the satellite imagery, or we'll be here all day. But as far as the other rover is concerned, I would point, for example, to our discovery of iron and magnesium carbonate minerals with Spirit. Carbonates are very difficult, as you, I'm sure, know, to create in an acid environment. So those carbonates probably also, at that landing site, point to a kind of a neutral chemistry there.
Okay, and that in terms of the timetable for that, I mean, I know that you're not able to kind of get fine-grained estimates of chronology, but do you have any sort of ballpark sense about whether there might be overlap?
I don't even want to take a swing at that one. Within a given landing site where we can see rocks piled on top of other rocks and work out the relative age, we can tell you this was older and this was younger. These are on opposite sides of the planet. They're both old, but in terms of relative age of those two, I don't even want to try.
All right. Thank you.
Sorry.
No worries.
Our next question comes from William Herkowitz at Popular Mechanics.
Perfect. I have a question for John. First of all, thank you all very much for this. So you mentioned that any day now could be the last day for Opportunity. Is there anything specifically that you're worried that might spell the end for Opportunity? And what actions are you taking to avert disaster?
Well, we don't know what would actually do in this rover. It is held up so well for so long. I would speculate that the first thing we would see would be degradation in its external mechanisms. We'd lose the ability to drive. We'd lose the ability to use a robotic arm. We'd lose the ability to slew the cameras or the high-gain antenna. Those are the kind of things that would allow for a controlled or graceful degradation to the vehicle, that we could still communicate, still interact with it each day. But internals, if we have a solder joint that breaks, then it's game over. It's instant death. But that said, the batteries are in good shape. There's been no indication of anything. It's difficult to trend things, but if we do all the usual measurements, blood tests, urine analysis tests, and the like, it still speaks to a reasonably healthy rover.
All right, thank you very much.
Okay, thank you. And we're going to take a question now that came in via our audience on the Ustream broadcast of this. And the question is, knowing what we know now, Would any future solar-powered vehicle include solar panel wipers to clear accumulated dust?
I'll take that one. They are considering solar power for future roving vehicles, and they have considered, dust mitigation devices for the solar arrays, but they all come with some cost and some complexity. I think what's being considered more likely is the ability to tilt the arrays, and this gives you two potential advantages. One is you could track the sun, like a sidereal stat, just like active solar panels here on the Earth. This would get away from having to find north-facing slopes in the wintertime like we're doing now for Opportunity. You could just motor drive the solar arrays, and then over the course of the day you track the sun as well, maximizing solar illumination. The other possible advantage for that is you could tilt those solar arrays dramatically if you are accumulating dust, and maybe the dust will fall off the arrays with such things. So that's sort of what's being thought of for that question.
Okay, thank you. And we're going to do a really quick, actually we have time for another question, and this one will come from Alexandra Witze of Nature. Hi.
Hi, my question is for John Callis. When are you going to break the distance driving record for Lunokhod?
That's kind of problematic, because we're unsure what the actual Lunokhod record is. Actually, I'll pitch it over to Steve, because he's been in touch with the Russians on that.
Yeah, sure. So we have enormous respect for what the Soviets managed to accomplish in 1973 with the technology of that day, and so we would not want to claim to have beaten a record until we're really sure that we did it. The problem is that at the time that was done, they didn't really have any good orbital images in which to operate, and so their estimate, which has been published for many years, of 37 kilometers is highly uncertain. And so what has changed since then is we've now got good orbital images of the moon that even show the Lunokhod rover tracks. There has been no solid effort yet to measure those tracks and figure out how far Lunokhod really went. And so we are just going to patiently wait until somebody, either in Russia or in the United States, comes up with a really well-calibrated number for how far Lunokhod actually drove, and then we'll see. But right now, we're just going to stand back and try to let somebody else figure out how far Lunokhod actually went.
Okay, well, that wraps things up. Kind of perfect timing here, and thank you to John and Ray and Steve. Appreciate your time, and to all of those who joined us today. And the telecon will be archived for 1 week, starting about an hour from now. It'll be archived for a week by calling the toll-free number 888-566-0697, or the international number is 402-998-0831. And it will be archived with visuals on Ustream at www.ustream.tv/NASAJPL2. And, of course, more information about the rovers, about opportunities online at www.nasa.gov/rovers. And on Facebook at facebook.com/MarsRovers, and the Twitter handle is @MarsRovers. Thanks for joining us today. Have a great day and a great weekend.
One is, how far is the rover going to be driving a day on an average? And the other, for either Steve or Ray, is about comparing a little bit, if you're able, what you've been able to learn from the Yellowknife Bay drill samples as far as the acidity of the water or anything else, minerals, to what you found with the rock that Opportunity was studying.
Range of motions. So the science team, which is led by the principal investigator, Scott Murchie from the Applied Physics Lab, is a little bit reticent about doing a lot of gimbaling. But this is such an important observation, I suspect I can talk him into it.
Great, thank you. Hope you have luck.
Our next question is from Irene Klotz at Reuters.
Thanks, Jane, and sorry for the background noise. I have two questions. One,
This is Steve. I can take a crack at those. To go after the second question first, I don't think any of us here want to speak for the MSL project. All of us are, well, a number of us are involved in that project, but I think if you've got questions about what has been discovered with Yellowknife Bay, those are questions that are best put to people who are representing the Curiosity Rover project. With respect to distance a day, it really varies. It depends on how much power we've got. It depends on how challenging the terrain is. The assumption that we have made is that we can achieve about 60 meters per drive between where we are and Solander Point, because that's what we've typically historically been able to achieve in the past. Sometimes it's better than that. We had a drive just the other day that was 102 meters. I think our most recent one was 65. But if we can maintain a steady pace of 60 meters per drive, which we have sort of demonstrated